So now that you've got the group thinking about serverless and the virtues of distributed architectures, our next panel is meant to equip all of you with a map of the emerging microservices ecosystem. And moderating this discussion is a true industry veteran that we're very excited to have with us here today. Our moderator will be Eric Knorr, who is editor-in-chief of InfoWorld. Just a few quick pieces of trivia on Eric's prolific tenure in this industry. Prior to joining InfoWorld, Eric served as editor of PC World magazine, was the creator of the best-selling book, The PC Bible, a founding editor of CNET, and a veteran of several .com endeavors. So Eric, we take it you know a thing or two about this industry. Thank you very much for moderating this conversation, and over to you.
Great. Thank you. Can everyone hear me? It's a small room, so even if the mic doesn't work, it's fine. If my panelists could join me here. We have, let's see, and also, good. William has joined us. All right, so to my left here, we have Ivan Dwyer. He's head of business development at Iron.io. Chad is CEO, so Ivan is handling biz dev. And then over further on my left there is Julio Tapia, who's the global director of the OpenShift Cloud Partner Ecosystem, and he's now leading a full-blown standards-compliant platform as a service. OpenShift is one of the top platforms as a service out there. And then on the extreme end there is William Morgan. He's CEO of Buoyant, which is makes Linkherd, a remote procedure call proxy for microservices. And on his LinkedIn bio, it says, I write code and convince people to do things. So welcome to all of our panelists here. First of all, I'd like to sort of parse out the microservices stack a little bit, right? I'm sure all you are familiar with the basic sort of groups of the cloud stack, the infrastructure as a service, platform as a service, software as a service. But since Chad didn't go very deep into the sort of stack of technology, maybe we could start with you, Ivan. You could talk a little bit about Iron.io and how it fits in, how your job processing play fits into the whole microservices stack.
Sure. Well, one thing that's interesting about microservices is that it's an architecture and it's a culture. But the ecosystem and the stack around it is really nothing new. We're more responding as an ecosystem to new patterns. So in terms of the infrastructure layer, the platform layer, the software as a service layer, things are kind of the same. But we're now seeing developers break things apart more, and we have to actually kind of respond to that and change the way we deliver our services. But from a stack, it's really kind of the same as what we're used to.
How about you, Julio? I mean, I guess part of what I'm getting at is, okay, we're breaking things from monolithic applications into individual services, right? Those services need to be managed. Those services need to be orchestrated. Those services need to communicate, right? They need to pass messages. So, there are a lot of moving parts in that layer of the stack, I guess you could put it that way.
Yeah, no, certainly. So again, my name is Julio. I'm from Red Hat. So I represent a product called OpenShift. And OpenShift, we were referencing it as a PaaS before. We're now kind of evolving to a container app platform. At the end of the day, it's a platform that enables and accelerates the app development process. So microservices to us, it's an app dev process, but we work with a lot of companies that are using our products to be able to create solutions with that architecture. So the ecosystem for us is working with a lot of ISVs, a lot of companies like Iron.io, like others, that have solutions that integrate on top of the platform that developers are going to use as they develop new applications. But it goes beyond just the ISV community. We work a lot with the system integrator community, so folks like Accenture and Wipro and TCS and many, many others, regional SIs. We also work with the cloud providers, the big hosting folks. So we work with Amazon. We just recently announced relationships with Google, with Microsoft, with T-Systems, with Telstra, with others. So for us, the ecosystem is wide and deep. From a technology perspective, I'm not going to get into deep into the weeds here, but at the end of the day, we support containers. We've been supporting them for a long time. We embraced Docker as a packaging format 3 years ago before they became the popular folks that they are. We're an open source company. We work with open source projects up in the community. Two of the big architectures that we support and that are baked into OpenShift is Docker, and then also Kubernetes, which is a big Google project that manages the orchestration among containers. So it is an evolving and complex platform, exciting, and the ecosystem to us adds a tremendous amount of value because the solutions on top of the platform is what makes life interesting for the developers and for the IT operations teams. And Chad did a great job outlining kind of how the technology has evolved. But generally, one of the hot topics today, beyond serverless, is also the DevOps area, and now IoT, and now blockchain. There's all these new things that are happening, but they fundamentally start with applications that are being developed, and they need to be developed quickly and efficiently.
Thank you, William. William?
Yeah, well, there's certainly a lot of stuff going on. You know, I think I come into this with kind of a weird perspective because I was an engineer at Twitter from 2010 to 2014, which is kind of during Twitter's very weirdly public infrastructure transformation from this monolithic app into a big microservices architecture. We didn't have that word at the time. You know, circa 2010, I think we might have had DevOps. We didn't know about containers. We didn't know about microservices. We just knew kind of, instinctively or somewhat intelligently, we knew kind of what we had to do to the system to make it work. And then emerging from that a couple of years later, and kind of looking around at the outside world, I was blown away by the fact that, wow, people are talking about containers, which we never had at Twitter. People are talking about scheduling layers. Well, we had Mesos at Twitter. That was good. But now there's Kubernetes. There's a bunch of other stuff. I think the ecosystem is really starting to evolve, especially around the technological kind of underpinnings that are there that enable a lot of this transformation to happen. And now looking back, to what life was like in 2010, I think much of what we had to do would have been a lot easier if we had containers and if we had systems like OpenShift or we had some of these underpinnings available.
Yeah. Well, William, that's really interesting. You were eyewitness to the breakup of a monolith, right?
Yes.
So how did that change the way things operated, in terms, both in terms of sort of the workflow inside of the company and the technology? Is there a way to summarize that fairly quickly?
It was a huge change.
Yeah.
I think, to me, the reasons why people like to talk about microservices and the reasons why we went into it at Twitter were we wanted to talk about, we wanted things to be scalable and we wanted them to be resilient. And we were thinking about very technical things. And I think the big benefit looking back at it was actually an organizational benefit, especially in terms of how the engineering org and the product org and the design org could interact. Once we had broken things down into different services, there was much less coordination that was required across the entire company in order to ship new features or in order to respond to incidents. And so I think that was the hugest difference. I don't think it was clear to us going into it. I think that was the biggest benefit. It was a very fundamental change to the way that we operated.
So the division of work among smaller teams, ownership of services, that kind of thing, kind of change.
Exactly, and kind of having a formalized boundary of communication between the teams. You would have to interact with the rest of the engineering org as an engineer, of course, but the way you would interact did not require you having to know everything about the entire system at every point in time. That was a big difference.
Right.
We're starting to see that in the ecosystem too. So before we'd have to do integrations, it would require a lot of engineering work. You'd have to get some architects on the whiteboard, but now it's all API driven. So if I want to run on top of OpenShift, I just extend their API to ours, and then we're able to just have our services running there. So that kind of like separation of internal culture has expanded now into the providers that are doing the technology. Just API level communication makes things a lot easier.
Right. So I mean, in some ways, breaking the monolith into services, there is a simplification that comes with that. In terms of lines of responsibility, being able to just have APIs, that kind of thing. But in terms of management and orchestration, it adds a lot of complexity. So what are you doing to address that?
Sure. Well, to extend what Chad was talking about, it's really our primary goal and responsibility to remove that from mind of our customers, but that means we have a lot of work to do to enable that. So we see this underlying container orchestration layer is obviously very important to distribute the workloads, distribute across different infrastructure providers, public and private. But we see the value of what this is bringing to the ecosystem is the next layer up. Is the actual end developers, end architects, and users are the ones building on top of what's provided. But we don't necessarily want to be the ones to have to be orchestrating containers under the hood. So our goal and our what we try to accomplish is to sit on top of all of those orchestration layers, provide a pure business layer platform, and then extend that to our customers through an API.
Great. Well, you're playing, Julio, you're playing more of a role on that orchestration layer.
Yeah, I mean, absolutely. So at the end of the day, we're all looking to abstract complexity from the whole process. And it goes up and down the stack. And then when it comes to the ecosystem, if you're a developer and you want to use a database, you want to be able to just use it, not necessarily have to worry about provisioning and configuring and testing and other things. Similar with the languages, with frameworks, you want an APM solution, you want a CI/CD solution, you want a testing and monitoring solution. You want to be able to just point and click and get things done so that you can develop your app to focus on the things that you're good at so that you can compete in the marketplace. So it's all a very interesting time. And to be honest, it's still early in the days of the ecosystem. There's many versions of what that looks like. You may have seen, I think Zevia Labs did an interesting approach with their periodic table. Take a look at that when you get a chance, and you'll see kind of how they look at it. Each of the elements is a particular part of the ecosystem, whether it's monitoring or infrastructure and so forth. There's many views of that ecosystem, and it's evolving. It's very interesting. It's an exciting time to be in tech. From the OpenShift perspective, we get to see a lot of the innovation that's going on in the industry, and so it's just an exciting time to be here.
Sure. And what's Red Hat's? I mean, Red Hat is really at the center of an ecosystem now, right? And what part of what I'm trying to get is why do we need one? I mean, we have public clouds. They have lots of tools on them. Why do we need to evolve a different ecosystem besides what Amazon offers, besides what Azure offers?
Well, I think at the end of the day, so Red Hat is an open source company. Everything we do is available upstream. The solutions, the partners that we interact with, sometimes they are open source, sometimes they're open core, sometimes they're proprietary. So it is a way to bring in all of the different partner types, solution types, and incorporate them in a way that's consumable and easy for developers to use. So is it a new ecosystem? I would say its functions might be the same, but the way they're interacting together is very different. It's much more open. From a customer perspective, and I've been with many, many large customers in countries around the world, and the issues tend to be the same. We don't want to be locked in. We want something that works. We want it to be affordable. We want it to be more of a partnership. And from a Red Hat perspective, those are areas that we've historically done well in. So it is a different ecosystem approach, but at the end of the day, it's the same problems that we've had in technology for many, many years. And I'm not as young as I look. I've got kids in college, so similar to the Chad stories, what my kids are doing today is very different from the way we grew up. It's an exciting time.
So William, I want to give you a chance here because you're attacking a very specific element, right? Remote procedure called proxy, right? And that has to do with communication among microservices, right? Why did you see that as a specific pain point?
Yeah, that's a good question. I think I'd like to echo the comment that James made very early on, which was that we kind of all know what the destination is, right? We know where we want to be. So the question is, how do we get there? And right now there's still a cost to doing this, the cost to adopting microservices, and there's still, this is why we're all going around having all these talks about microservices versus monoliths, and when's the right time to do this, and what are the trade-offs. And at some point, I think we're not going to do those talks anymore. We're not going to have those conversations anymore because that trade-off will have been paid off. And the way we pay off that trade-off is by building the tooling and the infrastructure and the building blocks that make adopting microservices just as cheap as adopting monoliths. So everything that we're building at Buoyant, certainly, and I think it's probably fair to say for many of the other companies, is based on experiences that we've had or based on ideas that we've had about how to pay down that cost and how to make kind of the fundamental building blocks available so that everyone can adopt microservices without having to pay the big cost. So in our case, one of the big lessons that we learned at Twitter running its particular, large-scale microservice architecture, again, at the time we didn't call it that, we called it an SOA, was that the communications layer between services was a thing that was actually very, very expensive and was a source of a lot of failures and a lot of strange error cases, many new and exciting ways to fail. So Twitter ended up investing very heavily, not only in the scheduling layer, but also in the communications layer. And it kind of makes sense. This is the thing that you're introducing. When you break your monolith into microservices, you've now introduced these little communication layers everywhere in your applications. It makes sense that this is also, this is the thing that's different. This is now probably the thing that's going to require a little bit of work to get it working right.
Right.
So that's why we started there. It's not the end goal for Buoyant, but it's the starting point.
Right. Yeah, it makes sense. And you're in addition to Ironworker, you also have IronMQ, right? So
Correct.
you're also playing. You're playing the messaging space as well, right? I mean, what InfoWorld did SOA to death. When we did 10 conferences on the topic and everything else. One of the things that characterized that era were these heavy-duty messaging buses, right? ESBs, right? And that's touted as one of the sort of legacy technologies. We want to leave that stuff behind, right? Putting too much intelligence in the bus is a really bad idea. But when I see something like IronMQ, I'm thinking, gee, are we moving back towards that era?
Well, I would say definitely not. I think we're kind of taking the concepts around that, and again, SOA might have some negative connotations, but it formed the foundation for what we're doing today. And if you take those and then apply some cloud-native technologies around them and cloud-native ways of communication, containerized technologies, REST APIs, HTTP, all of these nice things that now we have is basically table stakes for cloud applications. We still have communication layers. We still have asynchronous communication, which we handle very well, and synchronous communication, which they handle very well as well. And the idea is that enterprise workloads, they're not all the same. There's no way they're all going to be the same. So there are going to be different methods of communication, different ways of processing, different data sources, different everything. So we see that communication layer as a really critical kind of the backbone of the entire distributed system. And so we built IronMQ, and then that works as an independent service, or it works as the backbone of our entire platform. When you do serverless workloads, they go into a queue first, and then we have workers that grab those jobs, execute them in a container, and then destroy that container. But it's all kind of centered around the queue, which this is a really important piece. But it's not the old ESB of old.
More on the side of eventual consistency as opposed to...
Eventually, we'll get it right. I love those jokes.
I think there's, if I can jump in, I think there's a very interesting and long conversation we could have about why SOA failed ultimately. But I don't think that failure was a philosophical one. I think, the notion of breaking things down into components that are distinct and that can operate and communicate in some form is the right idea. This is something that we've done throughout the history of software architecture.
Well, following that line of thought, I mean, at a certain point, it seems like when you have large enterprises, multiple microservices applications, you begin to get to that scale. Don't you start to run up against those same SOA problems where you have one service that's being hit from all directions, and those kinds of problems at scale, Julia? Yeah.
Well, yeah, I mean. At the end, we're trying to standardize software. And we've seen standardization provide benefits in a number of industries. You look at the automobile industry with what Henry Ford did back in the day. The example that Chad mentioned with the shipping containers. There's numerous examples, Southwest with airlines and other things. So there's some benefits to standardizing. There's benefits in software as well. It does create challenges on the system in terms of how do you create applications that are often complex. Some of them are very simple. Others have multiple clusters, lots of different data types. And so there are definitely challenges that happen in software. It's what makes life interesting from a provider standpoint. So Red Hat I've been focusing on OpenShift because that's what I represent. But at the end of the day, we have the full stack, everything from RHEL to the OpenStack layer, cloud forms. We have the mobile side. So there's a whole solution of things that we offer. All of them are embracing containers and microservices. So at the end of the day, we're looking to abstract that complexity for the developer, for the IT organizations throughout the entire stack. And there are challenges that occur in orchestration, in complex apps, and that's what keeps life interesting from a provider perspective.
Yeah. Well, in the preparation, the call before this panel, one of the interesting things that you guys touched on that I hadn't heard before was that ISVs are now beginning to deliver, essentially like microservices, pre-built microservices components to deploy within, their own microservices ecosystem.
And no, I think that's true. So we see lots of ISVs that have various solutions. They're creating microservices to develop their own solution. And sometimes the components themselves are consumable by the enterprise, as are the solutions themselves. And the customers, the enterprise customers, are consuming both the solution and sometimes the actual microservices component. So we see bits of everything. And so it is a very interesting and complex environment.
Yeah, and if you look at what Chad mentioned about the algorithm economy, those are essentially microservices that are offered up as APIs. So if I need to run a specific algorithm, I know what the input is and I just get the output. That's a microservice that's being delivered to a developer. And it's just like, any API services that we're familiar with might use SendGrid to send an email or Twilio to send a push notification. Those are just microservices that are handed to a developer as an API. So there's just going to be more and more of those. So the ISVs might be a little more specific to do like image processing, video encoding, these kinds of things. But that stack is essentially a microservice that's delivered. And it can run on top of OpenShift and just be part of your application stack. Yeah.
So I'm wondering, and by the way, please feel free to jump in with any questions of your own. I think we only have, about 10 minutes left. Okay. So in terms of the types of applications that you're seeing out there, on the ground, particularly hybrid applications, because there's a real swing in that direction now, I think, in enterprises, distributing the application between on-premises and some cloud deployment. What are some of the applications you're seeing out there that are really exemplifying, what microservices are best at?
Well, one thing that's kind of enabling these hybrid technologies is the container, because it gives us the consistency that we really need. And with more kind of event-driven models of fire and forget, if we don't have that consistency, we can't really feel comfortable about hybrid configurations. So that is a really enabling technology. What we're seeing, at least on our end from Iron.io, we see a lot of cloud bursting. So we see really like heavy secured data intensive workloads being done on-prem, but sometimes a quick action can be just kind of scaled out pretty large at a cloud level.
And do you mean discrete jobs that are uploaded?
Yeah.
Or do you mean that, you hit a certain capacity and
a little bit of both.
Actual burst?
A little bit of both.
Okay.
Sometimes it is on the workload, so you can kind of say this one I'm okay with scaling out. There's nothing really to it in terms of like the data. It can be like sending an email or push notification. You can do that a billion times in the cloud. Medical data. If you need to do some encoding on that or some like really crunching of that, we see a lot of that in house. But our unit is a container. So the actual process of developing and building the job in our world is the same. You just determine where you want it to run, and that's the distinction that we make. And we see a lot of that. It's per workload.
We're seeing similar things. At the end, we see lots of enterprises still run their workloads in their data centers, but we're seeing a huge shift to leverage the cost efficiencies of public clouds. And now they want the choice. They want flexibility to use some in the data center, some on the cloud, and then also multi-cloud strategies. So they want to hedge their bets, not necessarily be tied to any one vendor for any one thing. So lots of people use Amazon, but now we're seeing more of a balanced approach to put workloads on Azure, to put workloads on Google Compute. So we're seeing a lot of different permutations. if you kind of flash forward, I think what you'll see is customers are going to want to have control and visibility, but they're going to want to have the flexibility to run on a variety of pieces of infrastructure. From a developer perspective, keep it simple. Develop my app, deploy the workloads in a variety of places, whatever is most cost efficient, and just make it easy. And so it's going to be it's a challenge, but it's something that we're seeing live today.
William, what are you seeing?
Yeah, I'll jump on the same bandwagon, which is a lot of the companies that Buoyant works with are very interested in things like very low latencies, very high uptimes. The website must be up, no matter what. And so the reason for them to become interested, even if they're large companies that have their own data centers, the reason for them to be interested in hybrid approaches where either it's multi-DC within data centers that they own and operate, or extending out and hybrid between on-prems and a cloud or private cloud. A lot of the reasons to do that are to have cross-zone failover and to have cross-zone tolerance for latency, or for anything happening kind of either on-prems or outside of their control. I think that whole situation gets a little bit more exacerbated as you move to the cloud, where less and less of the hardware is in your control. And you really don't have a lot of guarantees, and there's a variety of reasons why you want to do that. But one way or another, you have to be able to handle those situations, and things that you used to, I think, traditionally be able to deal with by running your own hardware. Now you have to deal with those problems at the software layer, which means you have to be able to fail over between zones, between data centers. So that's been a big driver that we've seen for hybrid.
So, here's a question that sort of panders to all you potential entrepreneurs out there. What are some of the areas that in the ecosystem that need filling in? What are some of the underdeveloped areas where there are opportunities for solutions? Obviously, William, you found one. And are there other areas where weaknesses in the microservices deployments now that could benefit from additional technology development?
Definitely. I would say monitoring and security is the biggest gap right now with microservices. It was a lot easier when we had monoliths because it was a very familiar kind of stack, and we could just put our New Relic agent, and then if we wanted to scale, we had just another instance of that application running. Now, we've got distributed applications, we've got events tied to devices, data is crossing the wire, we've got sensors all over the the world. We're walking down the street, we just captured 10 terabytes of data on the way to get a coffee in the morning. That data now needs to be encrypted. It needs all the applications and services need to be monitored, but at the individual level, but also as a whole application. Because at the end of the day, a microservices architecture is usually a single application comprised of many components. So when you think about monitoring, you think about the whole thing, but also each individual piece. And there's definitely a lot of new services kind of coming up that are starting to tackle that. But that's the biggest gap from my perspective that I've seen.
Yeah, no, I would agree. Security is a big one that I see. In general, the container infrastructure to really manage everything smoothly is still there's areas that still can be improved upon. We generally see there's things that are still being worked. So databases aren't quite as easy as they should be today. App monitoring to really see where everything is and at deeper levels is still something that's evolving. But yeah, no, I would say security, containerization, infrastructure overall, just to have it seamlessly work is still, an opportunity.
I saw a really funny slide recently, which I don't remember where it was, so I'm just going to steal it and claim it as my own. But in terms of containers as a developer are incredibly convenient and nice because it gives you this very nice bundling mechanism, and you kind of throw it over the wall to the ops team. And then as someone who has to put containers in production, well, now you just have to solve a couple minor issues around security and networking and storage. And these are substantial areas that I don't think have been fully addressed in terms of how do you actually run containers in production. So there's certainly a lot of opportunity around that. also jump on the security bandwagon, definitely. I think, especially as you end up moving into a world where you have schedulers that are moving containers around between machines. You know, there have been traditional approaches to doing kind of layer 4, layer 3 security that really start breaking down when, you know, your application, first of all, is composed of lots of different services, and that set of services changes over time. Every service is composed of many different instances, and those instances get scheduled between hosts or virtual hosts at any point in time. So, you know, trying to keep up with that level, you know, with that level of change by doing layer 4 approaches becomes increasingly more difficult. So security is a big one.
Right. Lots of complexity. And as far as some of those operations issues you were talking about before, hopefully the DevOps panel will.
Right. Yeah, so stay tuned for answers.
So,
I think we're doing.
I just want to end on a note. You know, we've been talking about kind of deep in the weeds on some of this stuff. At the end of the day, we're talking about software. And software is changing. You may have heard Mark Andreessen talk about how software is eating the world. He talked about that a few years ago. We're now living it. We're seeing all of these new applications that are coming out that are disintermediating industries. We've all heard the Uber examples. We've all heard the Airbnb examples. It's happening across all the different verticals in finance and everything. And what's fueling and powering that is software. And microservices and these technologies are enabling it. So it's a key time, and we're seeing a lot of changes as a result.
Yeah, let me second that. I mean, it's a really exciting time, and you know, watching computing distribute, as Chad was talking about, you know, we're right here at the ground floor of this. It's really exciting. So thank you guys very much. Ivan, Julio, William, thanks very much. Thank you.
Thank you.
Thanks, everybody.